Hey guys, I want to show you now the fan example in Amesim, in Simcenter Amesim. Um, Before we do so, we go to the LMS Imagine Lab Simcenter Amesim for students. I double click on the button and the screen for Amesim opens. You see your model screen, you see your library tree, and you see a lot of different elements. And now I want to do the example. At first it was done with a pneumatic library, more or less. You can have a look here at the different objects. And before I start, I have to make sure that I'm in sketch mode so I can paint something here on our screen. Okay, now I look at the models and I make it a bit bigger. At first, what I need, I want to make simulation of a fan, so I have to drag this pneumatic gas data model here onto the screen. Okay, second point is I need boundary conditions, and I use this boundary condition tool. You can make the screen a bit bigger with a mouse wheel. I rotate it, and let's have a short look at the quantities, at the properties. We have temperature as a boundary condition, temperature of the air. We have pressure of the air that goes into this object, and enthalpy and mass flow go outside of the object. So this will be a result of your simulation. You don't have to know it. And I need two boundary conditions. I copy this one and paste it again and just rotate it a bit. Rotate the selection like this. So I have boundary conditions in front of the fan and a boundary condition at the exit. And now you see they are highlighted in a dark color, so probably you can't use them. You have to finish the model. So I go to my signals and I need here this signal sync plug to close the model. I rotate it that you can looks a little bit nicer, and I plug it here on my first model, and I paste another one and I rotate it and plug it here. You can use Ctrl R to rotate. Now the plugs are closed, looks pretty good, everything is fine. Now I go back to my pneumatic library and I have to look for the fan. Here is my fan model, and you don't have to know any differential equations or a lot of background about theory of fans. You just drag it onto the screen and you connect it, press the left mouse button and connect your fan to the boundary conditions like this. Maybe shift it a bit to make it a bit nicer. So like this. And the model is also not finished yet, but it looks pretty nice. And now I want to mention one thing. If you want to know more about the fan theory, you can go to help and you can see here a lot of knowledge about this pneumatic fan object, about theory, about some tables you need, about theoretical background and formulas you need for enthalpy and here for efficiency. And that's something I really like, because the program is for free You can download it for free, but you get a lot of information and help and theoretical background about theory of fluid energy machines, autonomous systems, and it's a pretty cool thing. Okay, but we have to come back to our model. You see some plugs are not finished, so I have to go back to control, and now I choose constants. I need a constant for temperature, let's say 20 degree, and I have to choose a constant for the pressure, and we make this pressure some pascals higher than the pressure at the exit. Together, fluid flow. Like this. And now you see the dark highlighting changes to light highlighting, but something is missing at our fan. An important part is missing. We miss a friction. If you have a gear here or electric engine or some axis, we always have friction, and friction is not a pneumatic problem. So everything here, every pneumatic problem is highlighted in brown color, but the friction problem is a green color. Let's look. Maybe this one. That's a load. We take it and we connect it, and we can connect our pneumatic problem of the airflow of the van with the mechanical problem of this friction model, of this rotary load model. Okay, that's it more or less, guys. That's our first fan model is finished. We don't want to start a simulation now. This will be a bit more difficult, but this design is fine.